have a good one here. Are there any black holes near our galaxy?
Well, no, I would say not. I would say there's nothing's near in space. Close in space would be like the closest star is 4 light years away, Alpha Centauri. And a light year is the distance that light can travel in a year, traveling at the speed of light. The speed of light is approximately 300,000 kilometers per second. Well, to travel at that speed for one full year, you're going to travel almost 10 trillion kilometers. 10 trillion kilometers is just a staggering number. We can't even imagine what that actually is. And if the closest star is 4 of those, that would be 40 trillion kilometers to the nearest thing outside of our solar system.
Wow.
So to say, is there something near to us? There's nothing near to us. The core may collapse to a point of enormous density, yet maintaining a significant mass. So very high mass, very low volume results in a very deep curvature of the fabric of space-time, really generating what we know as a gravity well. And a gravity well would be something that, you fall into, but you don't come out. Now, just by comparison, Earth has generated a gravity well as well. That's why the moon goes around the Earth. There's an impression in the fabric of space-time, and this is the theory of general relativity. The moon rolls around this curvature, but you can escape this well. The well is not that significant. Like we've been able to build rockets that can escape it. If you travel at 11.2 kilometers per second, you can get out of this well. To get out of a gravity well generated by a black hole, you've got to travel greater than the speed of light. Well, the speed of light at 300,000 kilometers per second is an insurmountable speed. So once you're in, and you don't get out. These things they pop into existence and then they kind of reside there, and usually they come from at the end of a life of a massive star. The closest one to us that might be of interest is Betelgeuse. Betelgeuse is a red supergiant in the constellation Orion. Betelgeuse has been wildly fluctuating in its brightness and its luminosity over the last several months. And a lot of astronomers are watching it and thinking, wow, is Betelgeuse going to blow up? Because if that star dies, it will go supernova. And it's right there, sort of right in our eyes view. We can watch, we have a front row seat to this. If it blows up, that will be kind of neat. It may result in a black hole. Well, that would be the closest black hole to us if that ever happens. Now, will that happen? Well, sure, it'll happen anytime now, as long as you can accept that any time now could be as much as 10, 20, or 100,000 years.
Yeah, that's true. Time and space is
very different than time on Earth.
Right.
We can't compare the life of a star to the life of a human. A life of a human is a blink of an eye to the life of a star, and so it just carries on, and we can't draw these comparisons. They're just too vast for us to do so.
Okay, I think we should move on to life in outer space. Everyone wants to know, are there aliens out there? Where are these aliens?
Where are they anyway? Life in space may well exist. It might. In fact, if you went and played by the odds, it probably does. But we have no evidence. Now, the reason I say odds is because in the galaxy that we live in, the Milky Way, there are approximately 400 billion stars. Well, we now understand that planets are commonly orbiting stars. In fact, if you look at the stars at night, you could probably safely assume that 90% of them have planets orbiting them. So there are a lot of planets. In fact, there are more planets than there are stars. So if there's 400 billion stars, there might be 1 trillion planets. So that's just in our galaxy. And there's countless billions upon billions of galaxies. Now, to say that we're the only life form seems absurd. However, we have absolutely no evidence whatsoever to say otherwise. Why do we not start thinking and assuming that we are the only life form? Because thinking that way, we will be more inclined to take care of the planet that we actually have. Why does the universe have meaning? The meaning of the universe is there because we've given it meaning. It's like to say the shade of a tree is meaningful. Well, no, it's not. The only meaning of the shade of a tree is when you're hot on a summer day and you find comfort and relief in the shade of a tree. If you're not there to give it meaning, it's meaningless. So we're here to give the universe meaning. This is an interesting thought. It's a different way of approaching the idea of life in space. It could be that we are the only ones. Now, if we're not, why haven't we seen them? This is called the Fermi paradox. Enrico Fermi was a scientist in the early part of the 1900s, the 20th century, and he apparently was sitting around a table with a bunch of other scientists at lunchtime, and they got talking, and he said, look, if there's life out there, why haven't we heard from them? It became known as the Fermi paradox. So this is the idea. Number one, if there's life out there and they visited us, why did we not know? They would be more advanced than us. They would have to be, because if they've made the trip here, they have to know things that we don't know. So they will be more advanced. So you have to ask this question: should we be afraid of them? Well, if we're afraid, maybe we should be, because it would be no different than if you were to walk along a sidewalk and see an anthill. You wouldn't look at the ants and say, can I explain to you the structure of DNA and the methods of inheritance? No, you'd probably take your foot and swipe it away, because the ants they're so far below where we are intellectually. I wouldn't take the time to try to explain to them anything that I know. We would be the ants by comparison to any civilization that's been able to make the trip here. So would they try to communicate with us and explain to us their knowledge and ways, or would they just look at us like ants and wipe us off the earth? And that's what Stephen Hawking said, because in 1974, we sent a radio signal out into space intentionally to say, here we are. This is our solar system. We're on the third planet from the star. This is the star system around us. You can find us this way. Here's what we look like. Come find us. It's like, hello, we're here, we're here, we're here. And Stephen Hawking said, big mistake. You should never have done that.
Yeah.
Because now you've told everybody that we're here. Now, that was 1974. So where's that signal today? Well, that would be 46 years ago. In 46 years, it will now be 46 light years away. Well, what's within a radius of 46 light years? Well, not a heck of a lot. So if anybody has heard it, they would have had to have received it. They would have then had to interpret it. They would have had to look in the heavens and try to find us. And then they would have had to develop a system to get here, all in the last 46 years. So it's highly unlikely that anybody out there would even know that we're here. The sun is not a significant star. It's not particularly bright. It's not particularly large. Why would they even hunt here? There's no reason really to suspect that any alien civilization that even knows that we're here. So it just remains a mysterious question of the universe that we can sit around the campfire at night and talk.
One thing that I find really interesting about space is that when we're looking up at the stars, we're looking into the past. So could you talk about that a little bit?
Well, it's true. Like the Big Dipper is a part of the constellation called Ursa Major, and the average distance to those stars is about 100 light years. So you're seeing those stars as they were 100 years ago. You see, we ascribe human lifespans to stars. Just because a star's light traveled for 100 years does not mean that star is not there anymore. Of course, it's still there. The lifespan of a star is billions upon billions of years. So now another interesting one, though, is the Andromeda galaxy, which is about 2 million light years away. It's a very easy galaxy to find in a telescope. In fact, if you're in a dark enough sky, you can see it with the naked eye. Well, that light that you're receiving, think of those photons that are whistling across the cosmos. strikes you in the eye after traveling 2 million years. Now, what's interesting about that is you think, well, what was the Earth like 2 million years ago when that photon left its long voyage across the distance of the universe? Well, the Earth was far different. 2 million years ago, it's easy to look up what was the climate like, where were the continents, what about Pangea, and those sorts of interesting things. But if you could speak to the photon, you would say to the photon, "Wow, Mr. Photon, that was an incredible journey. You just took 2 million light years. You must be exhausted after that enormous trip of 2 million years." But to the photon would say to you, 2 million years? What are you talking about? I just left. Because the theory of special relativity says that at the speed of light, time becomes inconsequential. So to the photon, it left Andromeda and it arrived here, bang, bang. But from the observer on the Earth, we would observe it having traveled for 2 million years. And this is one of the bizarre concepts of space, and also one of the bizarre concepts of the speed of light.
Why are all the stars fixed in space? So that's what they were saying. Why does it always look the same?
Well, I mean, technically they're not. We are all orbiting the center of the galaxy. So they are moving. In fact, the sun takes about 2 million years to orbit the galaxy once. So we're orbiting the galaxy with the sun. Takes 2 million years to do. The stars do move. They do shift their position. In fact, if you waited long enough, several million years, the Big Dipper, as you know it, would not look like the Big Dipper anymore. One of the stars that you could look up is called Barnard's star. Barnard's star. It's the fastest moving star. It changes its position relative to the other stars faster than any other star. And so it's an interesting point, because it's an indication that the stars are in fact moving. But from our point of view, it doesn't appear to be. It's just the same as if you're looking at the Trans-Canada Highway from an airplane. Those little tiny cars on the highway that you can just barely see appear not to be moving, but they're going 100 kilometers an hour. That's fast, and yet from a distance they appear not to be moving at all. It's all a relative thing. So the stars are moving. It's just you'll never see them move in the lifespan of a human.
Why is space so empty? Thought that was a really interesting question.
The matter that we know to exist, the matter that we can see and touch, and the matter that we know is made up by the elements of the periodic table, will make up 4% of the entire universe. So we know this because the motions of the galaxies don't move relatively the way we expected based on the visible matter. Or in other words, if I could try to explain this better, the movement of the universe and the galaxies and the way they seem bound, there doesn't seem to be enough visible matter to cause enough gravity to allow that to happen. So they started to look in the 1950s at, is there something else out there? And it was theorized that there must be something else generating the gravity that we can't see. Not knowing what it was and not able to see it or measure it, it became known as dark matter. And to this day, we don't know exactly what dark matter is, but we know that it generates a gravity that maintains the positioning of the galaxies. So the universe is empty as far as we can see, but it's not empty as far as we can't see. It's kind of like saying I'm sitting in an empty room. Well, the reality is that's based on what I can see of the electromagnetic spectrum.
Right.
If I were to see all of the wavelengths of the electromagnetic spectrum, it would be very, very bright. There's radio waves in here, and there's probably microwaves, and there's probably all kinds of different things bouncing around this room, but I can't see them, so I say, oh, the room is empty. But in reality, if I take into consideration all of the energies, it's not very empty at all. And it's the same thing for the universe.